Okay, in this video, we're going to be looking at curves, polygons, and symmetry. Now, the only things I'm going to talk about will be more things that are on polygons. We'll look at congruent segments and angles, regular polygons, triangles and quadrilaterals, the hierarchy of polygons, and line symmetries. Now, we will not discuss the rotational or turn symmetries, or point symmetry, or the classification of figures by their symmetries. Okay. Let's start off with curves and polygons. A simple curve is a curve that does not cross itself. It starts and stops, and the starting points and the stopping points may be the same. So a polygon, a simple curve would look something like this. Starts here, can go anywhere, but it's going to end at the same point. So the starting point and the stopping points may be the same. It's a simple curve. And by the way, this would be an example of a closed curve, because that's a curve that starts and stops at the same point. And a polygon is a simple closed curve with sides that are line segments. This is an example of a polygon. Okay? The lines segments are the sides, and it is a closed curve. That means it starts and stops at the same point. A convex curve is a simple closed curve with no indentations, meaning that the segment connecting any 2 points in the interior of the curve is wholly contained in the interior of that curve. So I'll give you an example of a convex curve. This will be convex. Okay, because if I have any 2 points on the interior of this particular curve, that line segment connecting them is inside the curve. So in this case here, this is an example of a convex curve. Now in this case, a concave curve is not convex. In other words, it has an indentation. Let's say I had this. This is a concave. Here's the indentation right here. Because I can take a point, 2 points, one here and one here. That line segment would not be inside the polygon. Part of that line segment is on the outside. That's why it's a concave curve. It has an indentation in it. And these are some examples of what a simple curve looks like. On the left, you see what simple curves look like. Then you have a closed, and then from that we can weed out which ones are polygons, like this one, like these two here. These two are convex. These two are concave. These two have indentations in it. Okay. Every simple closed curve separates the plane into 3 disjoint subsets. That's the interior of the curve, that's this space on the inside, the exterior of the curve, which is on the outside, and the curve itself. So here we have a triangle. You have 3 different subsets in that plane. The interior of that triangle, the space on the outside of the triangle, and of course the triangle itself. Okay, and this is one question you can ask yourself: is point X inside or outside the simple closed curve? Okay, and in this case it will be on the outside. Okay, Let's look at the types of polygons that we have here and the number of sides and vertices. A triangle is a polygon. It has 3 sides. A quadrilateral is another type of polygon. It has 4 sides. Later on, we're going to be looking at the various types of quadrilaterals as well as the types of triangles that we can have. Next is a pentagon. It's 5 sides. And of course, you can relate that to the actual Pentagon building in Washington, D.C. That building is consisted of 5 sides. So a pentagon has 5 sides. A hexagon has 6 sides. A heptagon has 7 sides. Octagon has 8 sides. An illustration of that would be a stop sign. A stop sign has 8 sides. That's an illustration of an octagon. A nonagon has 9 sides, and then a decagon has 10 sides. And of course, an n-gon is just a geometric figure with n sides. Okay, some more stuff about polygons would be this. An interior angle is an angle formed by 2 sides of a polygon with a common vertex. Let me illustrate that to you. Let's say we have a pentagon that looks like this. Here's a pentagon. The interior angle is always on the inside because it's being formed by 2 sides of that polygon with that common vertex. So here, this will be the interior angle. Then you have an exterior angle of a convex polygon. That's formed by a side of the polygon and the extension of a contiguous side of the polygon. If I was to extend this side of the polygon like this, then this angle right here in red is your exterior angle. That's an exterior angle. And then next is a diagonal. It's a line segment connecting non-consecutive vertices of a polygon. Okay, so here, this is an example of a diagonal. This diagonal right here is connecting a non-consecutive vertices of the polygon. As these two are non-consecutive vertices, and that line segment would be your diagonal. Another diagonal will be from this vertex to a non-consecutive vertex of that polygon. Okay. And in this illustration here, you can see what the interior angle looks like. Okay, that's the angle that's on the inside of the polygon. And the diagonal is a line segment connecting 2 non-consecutive vertices. So A is being connected to C. That's a diagonal. Here's your exterior angle. It's on the outside. If you extended line segment CD to look like this, then angle 2 would be your exterior angle. Let's look at congruent segments and angles. Congruent parts are this: parts with the same size and shape. Congruent parts are the parts with the same size and shape. 2 lines segments are congruent, and this is the symbolic representation for is congruent to. That's the equal sign with the squiggly mark on top. Is congruent to. So 2 line segments are congruent if a tracing of one line segment can be fitted exactly on top of the other line segment. And also 2 angles are congruent if they have the same measure. Okay. So let's look at this here. In this case here, I can fit line segment AB on top of CD, line segment CD. And notice that these 2 markings here showing that line segment AB is congruent to line segment CD. And on the right, we got two angles, angle XY, well, ZYX and angle RQP. Both of these have a measure of 108 degrees, so we can say that angle ZYX is congruent to angle RQP. Okay, next is regular polygons. All sides are congruent and all angles are congruent in a regular polygon. So a regular polygon is not only equilateral, it's also equiangular. Equiangular means that all the angles in that polygon are equal. Equilateral means that all the sides are equal. So here we have a regular pentagon and also a regular hexagon. Here all the angles are congruent and all the sides in that polygon are congruent. Okay, let's look at triangles and quadrilaterals. First of all, let's look at the types of triangles that we have. One is a right triangle. It is a triangle that contains only one right angle. As you can see here, this is a triangle. If you see the box next to the vertex here, that tells you that you have a right angle there. And that triangle is considered to be a right triangle. An acute triangle is this. That's a triangle where all the angles are acute. So you have all these angles that are less than 90 degrees. So that means you have an acute triangle. And an obtuse triangle is a triangle containing one obtuse angle. Here's that obtuse angle here in this particular situation. So here we have the obtuse angle here. So that means that triangle is obtuse. Okay, now we can also identify triangles by sides. Those we looked at were by angles. These are by sides. A scalene triangle is a triangle with no congruent sides. So here if you have the three different markings here on this triangle, that means it's scalene. An isosceles triangle has at least two congruent sides. So here the same markings here on two of the sides, that means it's isosceles. And an equilateral triangle is a triangle with all three sides congruent. All three sides must have the same markings. Now keep in mind an equilateral triangle can also be considered an isosceles triangle because of the definition of an isosceles triangle. It's a triangle with at least two congruent sides. Alright, next is a trapezoid. It's a quadrilateral with at least one pair of parallel sides. So in this case here, let's say that this side on top is parallel to this side on the bottom. And this is the notation that we use to say that those two lines are parallel or two sides are parallel. In this case here, this will be considered a trapezoid because you only have one pair of parallel sides. Well, at least one pair of parallel sides. Now, a kite is a quadrilateral with two adjacent sides that are congruent, and the other two sides also congruent. Here we got two adjacent sides here. These two adjacent sides have the same measure. These two adjacent sides have the same measure. So that's considered to be a kite. An isosceles trapezoid is where we have congruent base angles. Okay, in a trapezoid, these non-intersecting sides, they're congruent. That means that the base angles are congruent as well. That's why it's an isosceles trapezoid. In a parallelogram, each pair of opposite sides are parallel. In other words, these two sides are parallel, and also these two opposite sides are parallel. So that means we have a parallelogram. And a rectangle is a parallelogram with a right angle. So here, rectangle has one right angle in it. So that means that it is a parallelogram, so we can consider that to be a rectangle. Then we have a rhombus. It's a parallelogram with two adjacent sides congruent. Okay, it's a parallelogram that looks like this. Okay, two adjacent sides congruent. This side and this side is congruent. Then this side and this side are also congruent. And also this side with this side is congruent. And the same thing here with these two sides. They are also congruent as well. So that's a rhombus. A square is a rectangle where two adjacent sides are congruent. That means that these two sides are congruent here. A rectangle has a right angle in it. Okay? So that's why a rectangle with all the sides equal to each other is a square. And this is the hierarchy among polygons here. Okay. So from a polygon, you can have a triangle or a quadrilateral. From triangles, you can have a scalene or isosceles. And from an isosceles, we can come up with an equilateral triangle because of the definition of a isosceles triangle. At least two of the sides are equal in measure. And from a quadrilateral, we can break that up from a kite, then a trapezoid. Now from a trapezoid, we can have a parallelogram or an isosceles trapezoid. Then from a parallelogram, we can have a rhombus or a rectangle. And from an isosceles trapezoid, we can also get a rectangle. And then from a rhombus or a rectangle, we can get a square. And also a kite, we can also get a rhombus as well. So these are just this is just a plain hierarchy of what those polygons are. And I'm going to briefly talk about what line symmetries are. Mathematically, a geometric figure has a line of symmetry called L if it is its own image under a reflection in L. And these are just some examples of what line symmetries are. And what symmetries are, it's just going to be a line drawn in such a way that one side is a reflection of the other. Like this one right here. If I draw a line going this way, like this, the left side has the mirror image of the right side, or the top has a mirror image of the bottom. And in this example, how many lines of symmetry can each drawing have? Like in this one right here, this one can have 6 lines of symmetry. Okay. This one only has 1. Because the left side has a mirror image of the right side. And for this oval right here, if I draw a line going horizontally this way, that can be symmetry because the top has a mirror image of the bottom, and this line vertically will have the left side the mirror image of the right side. So there are 2 lines of symmetry. This one would not. Okay. So that would conclude this particular video on curves, polygons, and just a brief synopsis on symmetry.